Welcome to the sixth video in the FISAB training series on European fire safety regulations for sandwich panel products. In this video, we will explore the fire resistance classifications of sandwich panels and their impact on safety. This graph illustrates the fire development curve showing the progression of a fire from its initial incipient stage through growth, flashover, and into the fully developed and decay phases. Resistance to fire is critical during the fully developed stage. This phase is characterized by high heat release, lateral flame spread, and the potential for smoke and toxic gas production. Resistance to fire is a building's product's ability to withstand fire by maintaining its load-bearing and/or separating capabilities for long enough time. For example, the following features could all be evidence of improvements in resistance to fire performance: longer load-bearing capacity in fire, longer structural integrity in fire, and finally, longer thermal insulation in fire. For fire resistance performance, we assess three key characteristics. One is R, load-bearing capacity. This measures the ability of a structure to withstand fire while supporting mechanical loads, maintaining stability for a specified duration. Second characteristic is E, integrity. This checks whether a separating element can prevent flames or hot gases from passing through to the unexposed side during fire exposure. Integrity is generally evaluated based on three things. 1. Cracks or openings. 2. Sustained flaming on the unexposed side. And lastly, ignition of a cotton pad, unless insulation is not required. In case load-bearing capacity fails, integrity also fails. The third characteristic is I, insulation. This evaluates the element's ability to block heat transfer to the unexposed side. For most elements, except doors and shutters, thermal insulation fails if the mean temperature rise exceeds 140 degrees Celsius or the maximum temperature rise at any point exceeds 180 degrees Celsius above the initial mean temperature. This slide explains the declaration of fire resistance performance, which is assessed using standard time intervals. Fire resistance ratings are measured in durations such as 60 and 90 minutes, reflecting how long a material or a system can maintain its performance under fire conditions. The performance is classified as a combination of the designated letters R, E, and I, load-bearing capacity, integrity, and insulation. The classification ranges from as short time as 10 minutes to longer times up to 3 hours. Thus, help us determine the suitability of materials for specific fire safety requirements. Here are some examples of fire resistance performance classifications for a building product. Each classification reflects the duration for which specific criteria are met. For REI 15, the product satisfies load-bearing capacity, integrity, and thermal insulation criteria for 15 minutes. For RE20, the product meets the load-bearing capacity and integrity criteria for 20 minutes. For EI45, the product ensures integrity and thermal insulation criteria for 45 minutes. Finally, for E60, the product meets the integrity criteria for 1 hour. These classifications help define the performance of materials during a fire, indicating their ability to maintain structural integrity, contain flames, and prevent heat transfer for a specified period. The limits for load-bearing capacity for walls and floors are measured by deformations. For flexurally loaded elements, such as floors and roofs, the rate of deformation or deflection is calculated using this equation, L squared divided by 400D. D refers to the depth of the element and L for the span of the element. The actual deformation limit or maximum deflection is expressed as L squared divided by 9000D in millimeter per minute. For actually loaded elements such as columns and walls, the rate of deformation is given by this equation, height of the element divided by 100. The deformation limit or maximum contraction is determined using this equation, 3h divided by 1000 in millimeter per minute. These formulas establish the criteria for ensuring the structural stability of building elements when subjected to fire-induced stresses. The standard temperature time and external fire exposure curves are the most relevant fire scenarios to consider for the purpose of this training. When the standard temperature versus time curve is applied as a basis for testing, it should be applied for the full duration of the test. This relationship, which is a model of a fully developed fire in a compartment, is given by this equation. And for external fire, this equation is applied. For fire resistance testing, first we will look at few general aspects of fire resistance testing, including test equipment and apparatus, test conditions, test specimen and installation, and test procedure. And then we will look at few fire resistance test case examples. There are four main types of sandwich panel structures that are tested for fire resistance performance: external walls, partition walls, ceilings, and load-bearing roofs. External wall panels are tested to ensure they can withstand fire exposure from both sides, maintaining their integrity and insulation properties to prevent fire spread and protect the building's exterior. Partition wall panels are evaluated for their ability to act as barriers between different compartments within a building. The test assesses their load-bearing capacity, integrity, and thermal insulation to ensure they prevent fire and smoke from spreading between rooms. Ceiling panels are tested for their resistance to fire exposure from below. This ensures that they can protect the upper floors from fire and heat, maintaining the building's structural stability and safety. Finally, for load-bearing roof panels, they are assessed for their performance under fire conditions, ensuring they can support structural loads and prevent roof collapse. This includes evaluating their load-bearing capacity, integrity, and insulation properties. Here is a video showing an example of a fire resistance testing for a wall element. This slide explains the fire resistance testing procedure as defined in SFS EN 1363-1. For load-bearing elements, the required test load must be applied at least 15 minutes before the test starts. During the test, the loads must remain constant. The test begins at the moment the heating curve program is activated, meaning when the burners are ignited. Then the elapsed time is recorded and all measurement and observation systems, both manual and automatic, are activated to monitor the following parameters. One is the furnace pressure and temperature. Second is average and maximum temperatures on the unexposed phase for the insulation criteria. Third is the downward deflection or axial deformation for load-bearing capacity criteria. Fourth is the visual observations for ignition of a cotton pad or sustained flaming for the integrity criteria. Fifth parameter is the surface opening, which is measured with gap gauges for the E integrity criteria as well. And on top of all that, other phenomena like smoke, cracking, melting, spalling, or material deattachment are observed. These steps ensure a standardized and comprehensive evaluation of the fire resistance performance of structural elements. This slide presents an example of fire resistance testing results according to the SFS EN 13631 standard. For load-bearing capacity, the test was discontinued at 128 minutes without failure. Similarly, for integrity and sustained flaming, there was no failure after 128 minutes when the test was stopped. Moreover, no gaps or openings occurred for 124 minutes. And for the cotton pad, the integrity criteria was maintained for 120 minutes. Lastly, the thermal insulation criteria was satisfied for 110 minutes. So, given all of that information, the classification results can be represented as either REI 90 or RE 120. For REI 90, the specimen satisfies load-bearing, integrity, and insulation criteria for at least 110 minutes. Therefore, 90 minutes is picked as the lowest possible fire resistance rating value. For RE 120, the component satisfies load-bearing and integrity criteria for at least 120 minutes. These classifications indicate the time periods the building element successfully meets specific fire resistance criteria. Here is a second example of fire resistance testing results interpretation. In this case, the test was discontinued after 66 minutes with no failure observed for the integrity criteria. Moreover, no gaps or openings occurred for 62 minutes. For the cotton pad, the integrity criteria was maintained for 42 minutes. For insulation criteria, the thermal insulation was effective for 41 minutes for area 1 and 25 minutes for area 2. According to all of these test measurements, the classification result for this element can be EI 20, since the element meets both integrity and insulation criteria for at least 25 minutes. Thus, the lowest possible fire resistance rating value of 20 minutes is selected. Or the classification results for the tested element can be E30, since the component satisfies the integrity criteria for at least 42 minutes. That means the resistance rating value of 30 minutes is selected since it is the lowest possible rating value. Fire resistance tests for walls made from prefabricated panels must comply with EN 1364-1 standard. This figure highlights the placement of thermocouples for temperature measurement. Red circles indicate points for measuring the average temperature rise, while blue rectangles show locations for tracking the maximum temperature rise. Additionally, the test includes the deflection measurement points. Here are some conditions to note about the test. All specimens should measure at least 2.8 to 3 meters unless naturally smaller. Only full panels or boards are used. That way we minimize cuts. Vertical or horizontal joints are included in the test if they exist in real-life use. One vertical edge is kept unrestrained. Failures within 150 mm of the edge are excluded. And finally, standard support conditions are followed wherever possible. This slide illustrates the test frame setup for fire resistance testing as per SFS EN 1364-1. The positioning of panels and joints varies depending on the case. For case A, a free edge is placed next to a full-width board or panel on the exposed face. In case B, if only one full-width panel is used, it is placed in the center with smaller panels, minimum 500 mm wide on each side. In case C, for smaller panels less than 500 mm wide, one is placed next to the free edge. For both cases D and E, when joints are part of the design, they should be included in the test specimen as they are. Additionally, vertical or horizontal joints are positioned 350 to 650 millimeters from the free edge on the unexposed face. Fixings and connection areas of the sandwich panel specimen in both vertical and horizontal orientation shall be according to practical use. However, there is few typical solutions that many times take place in testing arrangements, such as for restrained panel ends, angle profiles can be used to fix wall and ceiling on both sides, and also fix wall and floor on the exposed side. For bottom connection, U-profile can be used instead of angle profile to simulate more severe fire conditions. It is also important to note that both faces can be separately fixed to the ceiling or floor or by through fixing. Another consideration is that the fixed vertical edge of angle profiles shall be fixed to the concrete test frame to restrain the movement of the panel in the horizontal direction. Moreover, the free edge shall be filled with a non-combustible insulating material class A2, such as mineral wool, and held in place with profiles that are fixed to the sandwich panel. For vertical panel applications, both edges can be unrestrained where this conforms to the end-use application. If a panel shall be cut in width to fit the assembly into the test frame, the cut panel shall be mounted on the restrained vertical side. For horizontal panel applications, the top panel shall be either the smallest width panel or the panel with the cut edge. This corresponds with the end-use applications where the full panel width is always at the bottom. This is an example of fire resistance testing of self-supporting ceiling exposed to fire from below. Resistance to fire testing is applicable to different types of ceilings, which are either suspended by hangers, fixed directly to a supporting frame or construction, and self-supporting ceilings. Within the test method, the ceiling can be exposed to fire from below the ceiling or above the ceiling to simulate fire within the cavity above the ceiling. Note that a test result is not applicable to other ceiling types or fire exposure directions. This figure shows an example of self-supporting ceiling exposed to fire from above. When the ceiling in practice is equal to or greater than the size of the furnace opening, then it shall be tested at a size of at least 4 × 3 meters. The span of the ceiling shall be in the direction of the larger dimension, and the upper fire compartment closure shall form a cavity of a height of 1.5 to 2 meters. For a self-supporting ceiling, there shall be one free edge, which should be in the direction of the main supporting member, while other edges are fixed. Additionally, a gap of 25 mm to 50 mm shall exist within free edge and shall be packed with a resilient, non-combustible material to provide a seal without restricting freedom of movement. The specimen orientation shall be designed to represent the most tedious conditions by arranging the more critical components parallel to the longitudinal axis. To measure average temperature for insulation criteria, 5 thermocouples shall be evenly distributed over the test specimen to monitor the temperature of the unexposed surface of the ceiling. To measure the maximum temperature for insulation criteria, thermocouples shall be distributed over the unexposed surface of the ceiling at locations where higher temperatures might be expected, for example in the joints, edges, or metal fittings, etc. For integrity measurements, for practical and safety reasons, it is not possible to use gap gauges to evaluate integrity, and the visual assessment shall be used. Therefore, the unexposed face of the ceiling is monitored for integrity only by the cotton pad and sustained flaming method. Finally, the deflection on the ceiling midspan shall be measured and will be used later for catenary force calculations. This slide illustrates the fire resistance testing setup for load-bearing roofs following the SFS EN 1365-2 standard. The test uses a one-way pitched roof as an example, with a minimum exposed specimen size of 4 meter length and 3 meter width. Additionally, if a ceiling structure is present, the specimen dimensions must align with it. Moreover, the roof shape should reflect real-life applications, such as pitched, flat, or monopitch configurations. The specimen must also include all joints and junctions typically found in practice. Furthermore, the specimen edges can be fire protected for testing purposes. The load distribution during testing should replicate or exceed practical shear forces and moments. In addition, the furnace pressure is set 100 mm below the pressure reference line, while the thermocouples are positioned at the lowest side of the specimen's exposed surface. Deflection is measured at midspan or alternatively at the point where maximum deflection occurs. It's typically on the top surface. Finally, the testing process for load-bearing roofs and the evaluation of performance follow the same criteria as those discussed in previous tests. For floor or roof structural members that span one way only, the following specifications with respect to the span and length of the test specimen apply. Span to the support and span of the specimen are calculated according to the illustrations of the shown figure. Again, all the other testing parameters and arrangements are similar to what was presented earlier, so there is nothing new here. This slide concludes this video. In our next video, we will discuss the conditions of direct and extended applications of fire test results. Thank you for watching and see you in the next video.